Question number 6. Figure 6 shows mass number and atomic number for the nuclei of 5 different atoms. So mass number and atomic number. Remind yourself, mass number is basically sum of protons and neutrons, whereas the atomic number is just the amount of protons. So if I want to write them down together, I will write down here, it will be mass, and here it will be atomic number. So they've given this information in the form of graph. So here's the mass number, here's the atomic number. It says how many neutrons are there in a nucleus of atom A. Now before I work out the number of neutrons, I will write down A in this form. So I'll say A. What's the mass of A? The mass of A is 234, whereas the atomic number is 86. Now remind yourself, this is again P plus N. These are just P. So if you take the difference of these two numbers, you'll end up with the number of neutrons. So if you subtract 86 from 234, you'll be left with 148. So the amount of neutrons are 148. Next part says which two atoms in figure 6 are the same element. Same element means they must have same atomic number, because it is the atomic number that will determine to which element the atom belongs. So I can see here I've got only one with this atomic number, I've got only one with this atomic number, one with this atomic number, but E and D, they both have same atomic number. So in other words, I can say they are both isotopes of the same element. So I'm going to say D and E is the correct answer. Next part says nucleus B decays by emitting an alpha particle. So they've given us nucleus B. We can write down B in the desired format, which is B with the mass of 226 and the proton numbers, which is charge of 88. Let's reread this statement. It says nucleus B decays by emitting an alpha particle. So B will change into, let's say, C, and it will give out alpha particle. Now we have to remember, alpha particle has a mass of 4 and a charge of 2. Remind yourself that the mass is conserved and the charge is conserved in nuclear decay. So what will happen to this number 226? It will decrease by 4, it will become 222, and 88 will decrease by 2 and it will become 86. So what is the location of C on this graph? I can say C will have 222 and atomic number of 86. So this is where my C will be found now. It says draw an arrow on figure 7 to represent the alpha decay. All you have to do is that B will change into C. Next part says what is meant by random nature of radioactive decay. When radioactive decay takes place, unstable nuclei will change into stable nuclei. Random means we can't predict which nucleus will decay or change into a stable nucleus. Can't predict which nucleus will decay. Next part, this is an important question, so I recommend that you put star on your worksheet. A polonium PO nucleus decays by emitting an alpha particle and forming a lead Pb nucleus. So in this case, what has happened? Polonium has changed into lead. Now why did it change into a new element? It's not because decay has taken place, it is because the proton number has changed. The lead nucleus then decays by emitting a beta particle and forms a bismuth nucleus. This is what is happening now. Then this nucleus decays by emitting a beta particle and forms polonium nucleus. Now if you pay attention to it, this is your start and this is your end. So start and end are the same. Let's recall, what is alpha? Alpha is 4, 2. Beta is 0, minus 1. Here it is 0, minus 1. So I can see here mass went down and I can say charge went down. In this case, I can see mass unchanged, but charge has gone up. Here again, mass unchanged, but the charge has gone up. Now we can quantify it. Here charge went down by 2, here went up by 1, here went up by 1. I was able to work out this information based on the fact that the mass is conserved as well as the charge is conserved in a nuclear decay. Now the question says explain how these 3 decays result in a nucleus of original element polonium. So all you have to say is first decay, second decay, and third decay. So in first decay, you can say atomic number slash charge. What happened to it during the first decay? Atomic number or charge reduced by 2, so it's -2. In the second decay, it went up by 1. In the third decay, it went up by 1. So the net change is how much? Is equal to 0. If the net change is 0, this means I can say therefore proton number is unchanged. Hence, final nucleus still belongs to polonium. And that's my answer.